Very good morning to all of you. Again, confirm me is my screen is visible and my voice is clear. Please confirm me.
Yes, sir. Clear.
चलिए start कर देते हैं lecture. Last lecture हमने क्या discuss किया था? Can anyone tell me what supposed we have discussed in last lecture?
Stiffness.
Yes. चलिए सब लोग मेरे को चैट बॉक्स में आंसर देंगे. If my far end is fixed, listen to me very carefully. I am writing here. My question number 1. Okay. सभी को participate करना है compulsory. Question number 1. If my R end is fixed, what is the value? What is the value of the stiffness? टाइप करके लिखना है चैट बॉक्स. This is the question number 1. There are 70 students in the room. I want answer from each and every student. Please participate. My question number 2. If my far end is a hinge, in that case, chalo. After unko પછી આનો આન્સર આપજો. જે સ્ટુડન્ટે આન્સર નથી આપ્યો એ સ્ટુડન્ટ બે ફોર્મેટમાં આન્સર આપશે, આન્સર નંબર 1 and answer number 2. Okay, just write down answer number 1 and give me answer. Just write down answer number 2 and give me answer. Fast. चलिए. I want answer from all the runner. Please participate. Okay. You have a 2 question. One question is if far end is a fix, what is the value of stiffness? And second question is if far end is a hinge, what is your value of stiffness? Okay. Chaliye, fine. So I hope all of you are understand regarding the your structural configuration for our stiffness. If your far end is a fix, your value of stiffness will be a 4 EI by L, and if your far end is a hinge, your value of stiffness will be a 3 EI. Is it okay? Okay. So now I hope rough page to તમારી જોડે હશે. એક point note down કરવા કરી નાખો. If your far end is a fix, your value of stiffness will be a 4 EI by L, and symbol of stiffness, that is a K, capital K. Is it okay? And second, if your far end is a hinge, your value of stiffness is the 3 EI by L. Just note down it. Just note down. Chaliye. Next topic. Carryover factor. Suppose my beam is a fixed. Suppose AB is a fixed beam. Okay. Suppose AB is a fixed beam. Now we have already discussed in a last semester in a topic of the fixed beam. If your any support is rotated by angle theta, yes or no? ऐसा कुछ concept हमने cover किया था last semester में. For a fixed beam, if your support is rotated by theta angle, what is the value of your fixed end moment? Yes or no? Please confirm me. Please give me answer in chat box. नहीं पता है तो ना बोलो, कोई बात नहीं. I will cover you. ठीक है? Okay, no problem. अभी इतना याद रखिए. If your support is rotated by theta angle, then moment at that support, that should be equal to 4 EI theta by L. And moment at far support, that is the 2 EI theta by L. I am repeating my statement. If your support is rotated by an theta angle, in that case, support which is rotated by theta angle, friction moment of that particular support, that should be equals to 4 EI theta by L. And far end support or opposite support, that is equals to 2a theta by L. In this case, suppose your AB is the fixed beam. આટલું ક્લિયર છે બધાને? Is it clear to all of you? इतना क्लियर है? Please confirm me. I want answer from all the 80 students. Please participate. I don't like to tell all of you to turn on your camera, because I well know that if you are turn on your camera, there might be a more consumption of your internet also. Okay, so please participate in chat box. बाद में मेरे को ऐसा ना करना पड़े कि आप सभी को कैमरा ऑन करके बैठना, कंपल्सरी करना. Is it clear? Please confirm me. Only 2 students give me answer. Okay, fine. So now in this case, listen to me very carefully. AB is your fixed beam. Okay, this is your fixed beam. Okay, this is your fixed beam. This is your actual structure. In this particular structure, your support A is rotated by angle theta. Support A rotated by theta I. Due to point is A, that's why I am writing here theta I. So now, as per our discussion, if your support A is rotated by theta A, fixed moment at point A, that should be equals to 4a theta by L. I have already derived this equation in previous semester. Now in this semester, there is no need to derive this equation. So forget about that. Just remember this concept. And B point is your far end, because you have a consider rotation at point A. So your rotation at point B, that should be equals to 2e theta I by L. Yes or no? You keep in mind, actual rotation at theta B is equal to 0, because it is a fixed. Your support B is not rotated, but your rotation will be happen at only point A, but fixed moment should be transferred on both the junction or both the supports. So in that case, your rotation will be a same. Is it okay? Please confirm me. Sure, fine. So now in this case, what is your carryover? આપણે પહેલા carryover moment discuss કરીએ. Then after we will discuss carryover factor. Okay, first of all we will discuss a carryover moment. What is your carryover moment? Okay, ये पहला discuss करिए. So in this case of beam, far end is the fixed. This is your fixed end. Okay, applied at a near end. M dash is the moment produced at far end. This is your M dash moment. Okay, M dash is the moment produced at far end. And this M dash is nothing but carryover. Okay, this M dash is nothing but carryover moment. Okay, this M dash is nothing but carryover. Is it clear? What is M dash? What is carry? Actually, what is a carryover moment is clear. Moment produced at far end. Okay. So repeat करूँ ना मैं. Please tell me. M dash. Okay, M is the moment that is produced at your near end. M dash is the moment that is produced at far end. Okay, away from the joint. Far end produced by it. Okay, so M dash is always your moment produced at a far end. Okay, and that moment is nothing but carry over moment. In this case, your rotation is happened at point A. So we can say that point B is your far end. That's why far end moment is nothing but your carry over moment. Okay, and that's value is a 2EI by L. Now, suppose we will take a ratio of two moment. Suppose we will take a ratio of two moment. In that case, suppose we will take a ratio of two moment. Okay. Just a minute. આપણે એક બીજી વસ્તુ ડિસ્કસ કરીએ. સપોઝ આવી રીતનો કોઈ કેસ. Now we have already discussed if your far end is a hinge or roller. Suppose this is your far end. એવું વિચારેલો કે આ તમારો far end. અથવા એવું વિચારેલો આ તમારો far end. Okay, suppose your support is far end is a fixed or hinge. In that case, your stiffness K is equals to 3EI by. In that case, your stiffness equals to 3EI by. Yes or no? Yes or no? આટલો ક્લિયર છે? આપણે અહીંયા બે કોન્સેપ્ટને કમ્બાઈન કરીએ છીએ. અહીંયા આપણે બે કોન્સેપ્ટને કમ્બાઈન કરીએ. Now, suppose what is the definition of stiffness? Moment produced. What is the definition of stiffness? Moment for unit rotation. How can discuss કરેલું? M by theta. Yes or no? From that concept, if I want to calculate moment, so your moment will be equals to 3EI theta by L. Yes or no? Yes or no? Yes or no? Yes, moment per unit work. Can I say that your moment equals to 3I theta by? Now, concentrate here, a solid concentrate here. Suppose, what is the nature of point A? Can anyone tell me what is the nature of point A? Write down in chat box. Fixed, exactly. Fantastic. Chalo. If your far end is a fixed, why hinge? Why hinge? In this case, this is your case number A, and this is your case number B. I am now. આપણે case number B discuss કરી દીધો. Now we are discussing the case number A. In that case, what is the nature of support? Forgot about rotation. Rotation તો થાય છે, assume કરીએ. Okay. What is the nature of support? Fast चलो. Fixed support. Exactly. Your support is a fixed. चलिए same concept apply करिए. If your far end is a fixed, what is the value of stiffness K equals to 4EI by L? Yes or no? Yes or no? And we have an equation K is equals to M by theta. So can I say that moment equals to K theta? So my moment equals to 4EI theta by L. Everybody with me, is it clear or not? Is it clear or not? चले fine. अभी मेरे को now अबे मैंने इतलू को आ तो तुम्हारा fixed support. This is also fixed support. Okay. Now can I say that this support can able to carry a moment? Yes or no? This support can able to carry moment? Yes or no? Yes. Okay. Now suppose I am હવે reverse engineering apply કરીએ છીએ. Okay, suppose I am thinking that this is the point A, this is the point B. Suppose your point A is rotated by angle theta. In that case, what is the value of moment? What is the value of moment to produce what is the value of stiffness to produce a unit rotation? That is equal to 3I theta by L. In that case, your moment will be equal to 3I theta by L. Yes or no? So can I say that your value of moment at this point is nothing but 3EI theta by L? Yes or no? Is it clear or not? Please confirm. Keep in mind, मैंने यहाँ पे क्या consider किया है? If your support A is rotated by theta A जितना rotation आ रहा है, तो कितना moment आएगा? ये consider कर रहे हैं. ठीक है? So in that case, your moment will be equals to 3 EI theta by L. Sorry, this is a L. Now, can anyone tell me? Just a minute. Can anyone tell me what is the value of moment at theta B? Just see your concept. This is your moment M. I want this is your moment M dash. What is your moment M dash? First question is that M dash आएगा या नहीं आएगा? In this case, in case number B, you need to think by logically, okay, not by yes. पहले भणी तो लो स्क्रीनशॉट पाડવા દઈશ તમને. કેટલા સ્ટુડન્ટ એવું કહેશે કે મોમેન્ટ આવશે તો કેટલી આવશે એ પણ લો. Just think and give me answer. We have a sufficient time. Now we are planning to take a extra lecture from next week also. So don't worry about regarding the syllabus. Okay. कितना मोमेंट आएगा? चलिए. Now, chalo. First of all, give me answer regarding this. What is the nature of point? Just forgot about value of moment. Just give me a nature of moment B. माने केस नंबर B માં point B નો nature જાણો. ચલો. Roller. Everybody with me? Now, suppose roller નથી અને hinge છે તો પણ ચાલે. Yes or no? Roller નથી અને hinge છે તો પણ ચાલે. Everybody with me? Because behavior of the both support in terms of the moment carrying capacity are more or like same. Okay. So now tell me, is either a roller support or a hinge support can able to carry a moment? Can able to carry a moment? चलिए पहले मेरे ये आंसर नहीं. So can I say that there is a no carryover moment? Can I say that there is a no carryover moment? So if your far end is a hinge, or roller, so we need not to require any carryover. Yes or no? No carryover, zero. Is it clear or not? Please confirm me. So carryover. Now I am discussing regarding carryover moment. After carryover moment, we will discuss carryover factor because it is a part of the carryover. Because before learning the carryover factor, it is required to learn a carryover moment. So can I say that in this case your carryover moment should be equal to 0? But in this case, previous case, what is the value of the carryover moment? હાફ જેટલી છે એવું કહી શકાય. કેટલી carryover moment જાય છે? હાફ જેટલી જાય છે એવું કહી શકાય. If your far end is a fix, yes or no? Yes or no? This distribution is nothing but carryover factor. This distribution is nothing but carryover factor. Let's discuss. So let's we make a two statement. If your far end is fixed, in that case, value of carryover moment that should be equals to. Now I am discussing regarding carryover moment also. Students, please keep in mind, not a carryover factor. In second case, if your far end is a hinge oblique roller, in that case your value of carryover moment that is equal to. चलो पहला केस में कितने carryover moment आवશે? If your far end is a fix, in that case what is the value of carryover moment? Write down in chat box. Yes, 2 EI theta by L. Forgot about theta I, theta B. Simple wording, 2 I theta Y. And if your far end is, in that case, what is the value of carry or moment? 0. Everybody with me? આટલું clear છે બધાને? આટલું clear છે બધાને? ચલો next. Very important. Carry over factor. Carry over factor. Next is a carry over factor. Now, carry over factor, simple equation યાદ રાખવાનું છે. Carry over factor, simple equation યાદ રાખવાનું છે. That is equal to carry over factor. That is equal to moment produced at far end divided by moment produced at near end. Is it clear? Carry over factor, moment produced by far end divided by moment produced by near end. Is it clear? Last lecture પતે પછી screenshot પાડી લેજો. Okay? At the end of lecture, I will allow all of you for screenshot. So don't disturb the lecture, please. So now, suppose if your far end fixed, if your far end is fixed, in that case, carry over factor. ચલો far end fixed છે, તો moment produced at far end, that means દૂરના એન્ડ ઉપર કેટલી મોમેન્ટ હશે એ વિચારવાનું છે. કેટલી એ મોમેન્ટ છે? far end ની મોમેન્ટ એટલે m dash કહી શકાય? yes or no? This is your far end, this is your near end, so can I say that m dash divided by m? Yes or no? Can I say that m dash divided by m? That is equal to, can I say that 2 ei theta a divided by L divided by 4 ei theta a divided by L. Okay, so your ei is cancel out, your ll is cancel out, theta a is cancel out, so your carry over factor, that is equal to 2 by 4, that is nothing but 1 by 2. Is it clear or not? That is equal to 0.5. So in case of while the calculation, we need a one concept carry over factor. Okay, that means we need to transfer the moment from one end to another end. In which case, if your far end fixed, how much amount of moment to be required to transfer? 50%. 50% moment transfer કરી પડે એવું કહી શકાય? Yes or no? 0.5, that means 50% moment transfer કરી પડે એવું કહી શકાય? As per carry over factor. Okay, so carry over factor numerical example આજે ગણીએ છીએ, એમાં ખબર પડશે. Don't worry. Now, suppose if your far end is hinge or roller. Hinge or roller. In that case, what is the value of carry over factor? Far end moment m dash divided by m. Just see in a previous slide, what is the value of far end moment? 0 divided by 3 theta by L. So can I say that your carry over factor should be 0? Yes or no? So in simplified word, we conclude this particular topic here. If in a calculation, if your far end is fixed, need to transfer half moment at far end. Okay, far end કઈ રીતે કરશું એક્ઝામ્પલમાં જોઈએ છે. Because your carry over factor is 0.5. Is it clear or not? Please confirm me. In a calculation, is your if your far end is hinge or roller, in that case no need to transfer moment. Yes or no? Because your carryover factor is 0. Yes or no? Please confirm me. This is the most important concept. Is it clear or not? चलिए पहले मेरे को ये बताइए. I hope this is clear to all of you. I hope this is clear to all of you. Okay, fine. Sure. Next topic, distribution factor. Okay, you need to just remember equation of distribution factor. That is equals to चलो અહીંયા જ લખી દઈએ. Distribution factor, that is equals to stiffness of member. Distribution factor always member, એટલું યાદ રાખો. Stiffness of member divided by sum of the stiffness. Okay, divided by sum of the stiffness. कैसे कैलकुलेट करते हैं वो न्यूमेरिकल. ठीक है, is it clear? Now keep in mind, yes, k by sigma. So can I write this equation like this? Distribution factor, that is equals to k divided by sigma k. In case of sum of stiffness, you need to sum of stiffness for a joint. आपको एक ही joint consider करना है. Clear? कैसे consider करना है वो numerical problem में देखो. ठीक है, चलो fine. Before starting this numerical problem, you need to remember some of the fixed and moment equations. Okay, suppose you have a fixed beam. Subject to central point load. You need to remember fixed and moment A and B. Keep in mind, always left hand moment is anti-clockwise, right hand moment is a clockwise. Left hand moment anti-clockwise will be considered as a negative. Right hand moment clockwise moment considered as a positive. Is it clear? Simple anti-clockwise is negative, clockwise is positive. And your value of moment equals to WL by 8. Yes or no? Okay, આપણે last semester માં derive કરેલું. You need to remember this all equation. No? You need to remember. Fixed beam subjected to central point load. This is the case A. L by 2. This is the total length L. Okay. Second case is that your fixed beam that is a subjected to uniformly distributed load. Your fixed beam that is a subjected to uniformly distributed load. This is the point A. This is the point B. So your moment at left support and your moment at right support. This moment is WL square by 12. And this moment is WL square by 12. Clear? હું ફર્સ્ટ કેસ માટે ખાલી મોમેન્ટ લખી આપું છું. એવી જ મોમેન્ટ દરેક કેસમાં તમારે લખવાની રહેશે. હમણાં નહીં લખો ચાલશે, ન્યુમેરિકલ પ્રોબ્લેમમાં લખવાની રહેશે. અહીંયા હું MFAB ફિક્સ એન્ડ મોમેન્ટ એટલે MFAB લખીશ. ધેટ ઇઝ ઇક્વલ્સ ટુ નેચર ઇઝ એન્ટી ક્લોકવાઇઝ, ધેટ્સ વાય માઇનસ લખી શકાય. MFBA your nature is a clockwise, that's why plus WL by 8 લખી શકાય. Yes or no? Please confirm me. Same direct case में लखो. Same direct case. MFAB, MFBA. Is it clear? चलिए next. For a fixed beam that is subjected to eccentric load W, A and B distance. In that case, we have a two different moment. In that case, W AB square by L square for left hand point. W A B square by L square. W B A square by L square. Is it clear? Is it clear? MFAB that is equals to minus WA B square divided by L square. MFBA that is equals to W B A square divided by L square. Okay. So now next. Suppose this is your fixed beam. Is it subjected to eccentric moment M? Eccentrical moment like that means center money. In that case, you need to remember equation fixed and moment. MFAB that is equals to. Now, depending on nature of moment. Here, what is the nature of moment? Clockwise or anti-clockwise? What is the nature of moment? Clockwise or anti-clockwise? Clockwise. So if your moment is a clockwise, so both end moment will be a clockwise. Is it okay? જો તમારી moment clockwise હશે તો બંને anti moment આ કેસમાં clockwise આવશે. And value of moment equals to M B bracket માં 2A minus B divided by L square. MFAB ની વાત કરીએ. Similarly MFBA ની વાત કરું તો MA ઊંધું થઈ જશે 2B minus A divided by L square. Is it clear or not? Please confirm me. Why both are positive? Because your external moment is positive. But if your external moment is a negative, in that case, your value of moment will be a negative. I hope it is clear to all of you. Next, ની વાત કરીએ. If your any end is sink by delta, deflect by delta. Suppose point B is deflect by delta mm, just like this. Okay, just like this. In that case, can I say that here downward force is acting and here is upward force is acting? First of all, deciding that due to this two force, what is the nature of your moment? What is your nature of moment? What is your nature of moment due to these two forces? મારે point B નો downward direction માં deflection કરવા માટે પોઈન્ટ બી આગળ ડાઉનવર્ડ ડિરેક્શનમાં ફોર્સ આપવો પડશે, એના બેલેન્સ કરવા માટે મારા પોઈન્ટ એ પર અપવર્ડ ડિરેક્શનમાં ફોર્સ આપવો પડશે. So due to this, your nature of moment is the clockwise. Yes or no? Rotate these two arrow at a time. બંને arrow ને એક સાથે rotate કરો. Your nature of moment will be a clockwise. Yes or no? Simple આવો કેસ છે. આ બંને વેલ્યુને એક સાથે રોટેટ કરો તો તમારી ક્લોકવાઇઝ મૂવમેન્ટ બનશે કે એન્ટી ક્લોકવાઇઝ મૂવમેન્ટ બનશે? ફાસ્ટ ચલો. Clockwise. So to prevent this rotation, I need to produce a anti-clockwise movement in terms of the fixed moment. Is it okay? યાદ રાખવાનો છે concept. આ concept યાદ રાખવાનો છે. We have already discussed in previous semester. So these two are anti-clockwise moment. This is your MFEB. This is your MFBA. In both case, your producing moment will be the same. MFAB equals to MFBA. That is equals to 6 EI delta by L. Anti-clockwise એટલે negative લખું છું. 6 EI delta by L. Is it clear? Delta by L square. Yes or no? Please confirm me fast. ખબર પડી? એન્ટી ક્લોકવાઇઝ કે કેવી મોમેન્ટ પ્રોડ્યુસ થાય છે? એક્સટર્નલ લોડના કારણે કેવી ડિફ્લેક્શનના કારણે કેવી મોમેન્ટ પ્રોડ્યુસ થાય છે? પોઈન્ટ બી આગળનો ડાઉનવર્ડ ફોર્સ, પોઈન્ટ એ આગળનો અપવર્ડ ફોર્સ, બંને એરોને એક સાથે રોટેટ કરો, કેવી મોમેન્ટ પ્રોડ્યુસ થશે? Rotate arrow at point A and arrow at point B at a time. Just visualize that which kind of moment will be produced. Just visualize that. Due to deflection. ચલો હજુ ખબર નથી પડી તો એક સિમ્પલ વસ્તુ વિચારો, પોઈન્ટ બી પર ડેલ્ટા જેટલું ડિફ્લેક્શન ડાઉનવર્ડ ડિરેક્શનમાં કરાવવા શું કરવું પડે? મારે ડાઉનવર્ડ ફોર્સ એપ્લાય કરવો પડે? યસ ઓર નો? ડાઉનવર્ડ ફોર્સ એપ્લાય કરવો પડે કે ના કરવો પડે? એના બેલેન્સ કરવા મારે પોઈન્ટ એ આગળ અપવર્ડ ફોર્સ એપ્લાય કરવો પડે બેલેન્સ રાખવા માટે. So now these two force એક સાથે રોટેટ કરો, it will produce a clockwise movement. So now this is your moment into deflection, but આ મોમેન્ટને પ્રિવેન્ટ કરવા માટે મારે ઓપોઝિટ ડાયરેક્શનમાં મોમેન્ટ આપવી પડશે. yes or no? And that moment will be a fixed moment, MFB and MFB. Okay, so now મારે આ ફોર્સની વેલ્યુ જોઈએ છે. આ ફોર્સની વેલ્યુની મારે જરૂર પડશે ન્યુમેરિકલ એક્ઝામ્પલ એટલે આપણે અહીંયા જ કેલ્ક્યુલેટ કરી દઈએ. So we have an equation, moment equals to force into distance, and your distance is L. So can I say that force equals to M by L? Can I say that your force equals to M by L? Just a minute, student. Just a minute, hold on. Now I want to calculate force. So can I say that force equals to moment by length? Actually M by D. D is equals to nothing but your length. Okay, so now in this case we have a two moment, MFAB and MFBA. So can I say that force equals to MFAB divided by L plus MFBA divided by L? So your value of force will be equal to minus 6 EI delta by L. L square into L, L cube થઈ જશે. yes or no? Minus 6 EI delta by L cube. So your force will be 12 EI delta by L cube. Is it clear? Please confirm me. Okay, I hope this concept is clear to all. I hope this concept is clear. Minus કરેલા plus કરેલો પછી ડિસ્કસ કરીશું, but your value of force will be equal to 12 EI delta by LQ. Now ચલો હજુ આ કોન્સેપ્ટને થોડો સિમ્પ્લિફાઈ કરીએ, ગોખી નથી મારવાનું. Suppose your point A is a sink by delta. Your point A is a sink by delta. આવો કોઈ કેસ છે. In that case, we need to apply here downward force, yes or no? We need to apply upward force here. In that case, what is the nature of producing moment? In that case, what is the nature of producing moment? Anti-clockwise. So we need to apply a clockwise moment at as a fixed moment. Is it clear or not? Value should be the same. Value should be the same. MFAB equals to MFBA. That's it. That should be equals to 6 EI delta by L square. Your force will be same 12 EI delta by LQ. Is it clear or not? Please confirm me. Okay, fine. Suppose if your support is rotated by angle theta, in that case this concept is already discussed. Okay, suppose rotation value is the clockwise. Suppose keep in mind your rotation theta is equals to clockwise nature. In that case your producing moment will be a clockwise. Yes or no? J support rotate hase ત્યાં 4 EI theta by L, opposite ઉપર 2 EI theta by L. In this case, I need to produce anti-clockwise moment by formation of forces. So can I say that this kind of force system will produce anti-clockwise moment? Rotate these two arrows at a time, it will give anti-clockwise moment. And what is the value of force? Force equals to same. Sorry. Force equals to moment divided by distance. So that is equals to 4 EI theta by L into L. That is equals to 4 EI theta by L plus 2 EI theta by L. That is nothing but 6 EI theta divided by L into L square. Yes, is it clear or not? Please confirm me. Just like previous case. Okay, you can do separate calculations also. બંને મોમેન્ટને અલગ અલગ એડ કરો અને પછી કરશો તો પણ 6 થીટા બાય L સ્ક્વેર જ આવશે. So I hope this is clear to all of you. Okay, suppose anti clockwise rotation હશે તો આને તમારે clockwise માં represent કરો. Okay, ચલો fine. I hope અહીંયા સુધી કોઈને confusion નહીં. Is it clear? Okay, fine. चलो आनो स्नैपशॉट ले लो. થઈ ગયું? આ સ્લાઇડ નો સ્નેપશોટ લઈ લો. Done. Third one. Fourth. Fifth. Clear? Let's confirm it. Is it clear? Okay, fine. Charlie, fine. Is screen is visible to all of you?
Yes, sir.
Fine. Fatapat, huh? Write down the statement. Don't worry. Again, this is not your part of syllabus, but જે સિલેબસમાં છે ને આપણે લાઈવ જ ગણીશું. ઓકે, analyze the beam shown in figure by moment distribution method and draw shear force and bending moment diagram. This beam have a constant EI for boss. Okay. This is your beam. So now can I say that A, B, C, 3 support chair? As per discussed in previous lecture, your all the intermediate support will be a which kind of support? Tell me in chat box. બધા intermediate support ને કેવા support ગણીશું? As per discussed in previous lecture. Can I say that your point B is an intermediate, not your end? વચ્ચેનો કોઈ support છે તેનો intermediate support કહી શકું? So all the intermediate support કેવા ગણતા હતા આપણે? Last lecture માં તમને already discuss કરેલું મેં. ચલો. કોઈને યાદ છે? છે કોઈને યાદ? So લખવટ લખી રાખો. Yes, કોઈ પણ intermediate support હશે એને આપણે ફિક્સ કન્સિડર કરીશું, not a simple. લખવટ નોટ ડાઉન કરી રાખો. Any intermediate support will be considered as a fixed support. Okay, any intermediate support will be considered as a fixed support. So can I say that your point B is your not a end support, this is your intermediate support. So this support will be considered as a fixed support. Okay. चलो, as per discussed, point B આગળ ઉભા રહી જાઓ. Keep in mind, distribution factor calculate કરવો હોય, તો minimum 2 મેમ્બર જોઈએ. કેટલા મેમ્બર જોઈશે મિનિમમ? To calculate distribution factor, we need a minimum 2 member. Is it clear? Is it clear? Yes or no? Fast. चलो, point A આગળ ઉભા રહો. Joint A આગળ ઉભા રહો. Joint A આગળ કેટલા મેમ્બર મળે છે? Joint A આગળ કેટલા મેમ્બર મળે છે? As this joint કેટલા મેમ્બર છે? We have 2 member A, B and BC. In this structure we have 2 member A, B and BC. બે જ મેમ્બર છે. ચલો હવે મને કહો જોઈન્ટ A આગળ ઉભો રહીશ તો મને કેટલા મેમ્બર મળશે? 22 students. Now please give me answer. Just one. Okay, fine. So एक सपोर्ट होय, एक मेंबर होय तो डिस्ट्रीब्यूशन फैक्टर મળે ના મળે? જોઈન્ટ એ આગળ ડિસ્ટ્રીબ્યુશન ફેક્ટર મળશે નહીં. ચલો થોડીક પ્રેક્ટિસ કરીએ સ્ટીફનેસ શોધવાની. પોઈન્ટ એ નો ફાર એન્ડ બી કેવો છે? નહીં, not ruler. We have already discussed which kind of this support. Intermediate, that means fixed. If your far end is a fix, your value of stiffness, keep in mind stiffness તમને મેમ્બર ની મળશે. તો A આગળ ઉભો છું તો કે એ બી કહી શકાય. સ્ટીફનેસ ફોર એ બી કેટલી આવશે? કેટલી આવશે? If your parent fixed, what is the value of your stiffness? Yes, 4 EI by L. ચલો પોઈન્ટ બી આગળ ઉભા રહી જાઓ. લેટ રિમૂવ ધીસ. પોઈન્ટ બી આગળ ઉભા રહી જાઓ. કેટલા મેમ્બર મળે છે? પોઈન્ટ બી આગળ ઉભા રહી જાઓ. કેટલા મેમ્બર મળશે? 2. One is the BA, second is the BC. Yes or no? ચલો વિચારો પોઈન્ટ બી નો ફાર એન્ડ કેવો છે? લેફ્ટ સાઈડ નો ફાર એન્ડ કેવો છે? Please give me answer first. I will finish this lecture before 12. Yeah, before 12. Don't worry. Please give me answer as a direct. Okay, Dhaval, direct select કરી દે. Direct select કરી. Everyone ની જગ્યાએ direct select કરી દે. Okay. Yes, your far end is a hinge. Now, in this case, what is your value of stiffness? K, B, A. કેટલી stiffness આવશે? Yes, 3 EI by L. ચલો પોઈન્ટ બી નો ફાર એન્ડ C કેવો છે? Yes, in that case, what is the value of stiffness? Yes, roller or hinge, that is okay. What is the value of stiffness? Yes, 3 EI by L. Is it clear? આ તમે ઇન્ડિવિડ્યુઅલ મેમ્બરની સ્ટીફનેસ શોધી. ઇન્ડિવિડ્યુઅલ મેમ્બરની સ્ટીફનેસ શોધી. નાઉ એટ પોઈન્ટ બી તમારી જોડે કેટલા મેમ્બર છે? પોઈન્ટ બી આગળ કેટલા મેમ્બર તમારી જોડે અવેલેબલ છે? Why 2 EI by L? 3 EI by L જ આવે. 2 EI by L is wrong. 2 મેમ્બર. તમારી ટોટલ સ્ટીફનેસ કેટલી થાય? સિગ્મા કે that is equals to KBA plus KBC. Yes or no? બંને મેમ્બરની સ્ટીફનેસ નું સમેશન. Yes or no? 3 EI by L plus 3 EI by L, that means 6 EI by L થાય. Yes or no? Actually આ રીતે કેલ્ક્યુલેટ ના થાય કેમ કે જો વેલ્યુ ઓફ EI અલગ અલગ હોય તો બંને વેલ્યુ બદલાઈ જશે, પણ રફલી જોઈએ તો 6 EI by L થાય એવું કહી શકાય. Yes or no? So distribution factor મેં તમને કીધું એ પ્રમાણે મેમ્બર નો હોય. distribution factor મેં તમને કીધું એ પ્રમાણે મેમ્બર નો હોય તો your distribution factor for a member AB, sorry BA, that is equals to KBA divided by sigma K, and distribution factor for BC member, that is nothing but KBC divided by sigma K. Yes or no? That means 3 EI divided by L divided by 6 EI divided by L. LL cancel out, EI cancel out, that means 1/2 આવશે, 0.5 આવશે. Yes or no? Yes or no? Your distribution factor will be a 0.5 for બંને મેમ્બર માટે તમારો distribution factor 0.5 આવશે એવું કહી શકાય. આ કેસમાં બરાબર. કીપ ઇન માઇન્ડ કોઈ પણ જોઈન્ટ આગળ ઉભાઈએ એ જોઈન્ટ આગળ જેટલા પણ મેમ્બર હોય બધા જ મેમ્બરનો ડિસ્ટ્રીબ્યુશન ફેક્ટરનો સમેશન 1 થવો જોઈએ. Is it clear? ડિસ્ટ્રીબ્યુશન ફેક્ટરનો ફાઇનલ નંબર 1 થવો જોઈએ. ભલે 2 મેમ્બર હોય, 3 મેમ્બર હોય, 10 મેમ્બર. Your value of distribution factor must be a 1. Is it clear? Sure, fine. Now, small homework to all of you. Before attending next extra lecture, you need to calculate distribution factor for આવશે. તમારે શું કરવાનું છે, દરેક મેમ્બરના સ્ટીફનેસ શોધવાના અને દરેક મેમ્બરના ડિસ્ટ્રીબ્યુશન ફેક્ટર શોધવાના. હિન્ટ આપી દઉં, હિન્ટ તમને આપી દઉં. જોઈન્ટ એ આગળ ઉભો રહીશ, જોઈન્ટ એ આગળ ઉભો રહીશ તો મેમ્બર કહીશ એ બી. ઓકે, તો સ્ટીફનેસ ન કહીશ કે એ બી કહી શકાય. જોઈન્ટ એ આગળ ઉભો રહું તો, જોઈન્ટ બી આગળ ઉભો રહું તો સ્ટીફનેસ કે બી એ આવે અને સ્ટીફનેસ કે બી સી આવે. યસ ઓર નો? જોઈન્ટ સી આગળ ઉભો રહું તો સ્ટીફનેસ કે સી બી, સ્ટીફનેસ કે સી ડી. યસ ઓર નો? પ્લીઝ કન્ફર્મ યે ફાસ્ટ. Similarly, point D આગળ ઉભો રહું તો સ્ટીફનેસ કહેવાય KDC. Is it clear or not? Is it clear or not? I hope this is clear to all of you. પહેલા તમારે શું કરવાનું, અલગ અલગ મેમ્બરની ઇન્ડિવિડ્યુઅલ સ્ટીફનેસ શોધી નાખો. Then after you have an equation of distribution factor K divided by sigma K. Keep in mind as per our discussion distribution factor ક્યાં મળશે, જ્યાં મિનિમમ બે મેમ્બર હશે ત્યાં. ઓકે, બે થી વધારે ચાલે પણ મિનિમમ બે હોવા જોઈએ. નાઉ ઇન ધીસ કેસ પોઈન્ટ બી એન્ડ પોઈન્ટ સી નો નેચર કેવો કહેવાશે? કેન એનીવન ટેલ મી? પોઈન્ટ બી અને પોઈન્ટ સી નો નેચર કેવો કહેવાશે? કેન એનીવન ટેલ મી? Yes, intermediate, that means which kind? Intermediate, that means which kind? Yes, fine. So now give me a quick feedback. All of you are able to understand this topic? All of you are able to understand? Please confirm me. તમને બધાને ખબર પડી કે નહીં? No buttering. Write down in chat box. ખબર પડે તો હા પડો, ના ખબર પડે તો ના પડે. Okay, fine. Just a minute. Now, દરેક સ્ટુડન્ટે ચેટ બોક્સમાં I am present છે એવું લખી દો. ચેટ બોક્સમાં લખી દો I am present. ઓકે, જેને લખાઈ ગયું એ લીવ થઈ શકે, જેને લખાઈ ગયું હોય એ લીવ થઈ શકે. ઓકે, નાઉ બિફોર લીવિંગ ધેટ just a minute. Our extra lecture is at this Tuesday. Okay, date is 22. Is it clear? મંગળવારે તમારો એક્સ્ટ્રા લેક્ચર છે. ટાઈમ વિલ બી આફ્ટર 2:30. સો તમને એક ગેપ પણ મળી રહેશે. Is it clear? No need to write down enrollment number, just write down I am present. Enrollment number લખશો તો ચાલશે. Okay, so extra lecture is about 22. મંગળવારે તમારો એક્સ્ટ્રા લેક્ચર છે. Is it clear or not? Just a minute. સ્ક્રીનશોટ પાડવા દઉં છું. Just a minute. તમે સ્ક્રીનશોટ વાળા ટાઈમ આપો. take the screenshot. Done. So let's we are wrap up the session. We will meet again Tuesday. Okay, after 2:30. Have a nice weekend.